Now we are in the unit 5, that is software engineering tools. In the software engineering tools we are going to discuss about specification methods, interface building tools, interaction devices, keyboard and functioning keys. And then pointing devices, speech recognition, digitization and generation, image and video displays and drivers. These are the topics we are going to discuss under the banner of software tools. Introduction. These tools are increasingly graphical in their user interfaces, enabling designers and programmers to build interfaces rapidly by dragging components and linking functions together. The main intention of these tools is to increase graphical user interface. Graphical user interface is nothing but enabling the programmers as well as the designers to build an interface that is rapidly dragging components. When you are using MS Paint, Microsoft Paint, or when you are using the devices like that, you are just dragging a tool, just like dragging the brush for painting, or dragging some eraser, dragging a pen. You are whatever the images which are available at that side, you are dragging that and using that one. That all comes under the graphical user interfaces, which makes easy for the user to use that particular tool. Which gives the more understanding to the user. User interface building tools have matured rapidly in the past few years and have radically changed the nature of software development. A major development in the field of user interface design is that the desktop computer is losing its predominance as the primary platform of interactive application. Most of the times we are using interface desktop computer is a major user interface device. Now it is losing its predominance, and primarily the platform of interactive applications came into existence. In addition to the huge diverse web development, there are a growing number of interaction capability machines such as mobile devices, cell phones, pocket PCs, game consoles, auditory interfaces and appliances with displays. We are not having only computer desktop as the display. We are having so many display devices, that is just like your mobile having its own display, and you can interact with your mobile with the help of that display. Cell phone, pocket PCs, game consoles, auditory interfaces, like that there are so many display devices came into existence. This means that the new software tools must support greater plasticity in the interface. Users should be able to switch from larger to smaller displays. Whereas the computer display is very large when compared to your cell phone display. So the user should be able to switch from larger display to smaller display, or even to telephone access to web services. And then user should be able to control the window size, font, colors and background, and possibly convert the text into foreign languages. The user has to be able to control the window size and what fonts we are going to use, what colors, what background we have to choose. The user can choose depending upon its depending upon the user's interest. It is he is or he are going to choose their background, the foreground and the colors. And possibly convert the text to the foreign languages. Even whatever the language we are using, the system can change. Your mobile can display the content in Telugu, display the content in Hindi, display the content in English. Nothing but the conversion of text from one language to another language. And the requirement of universal usability means that the content transformation need to be specified under device independent programming is of greater importance. Hopefully, even if the details change in the software tools, the principle will remain stable and valid across all the platforms. Specification methods. The first asset of making design is a good notation to record. Okay. Whatever you are designing, you must record it. The most important notation is the design is a good notation to record and discuss alternate possibilities. Whenever you record your design, then you can think of about different possibilities of making that one. That is the first specification. And then the default language for specification in any field is the designer's natural language. Okay. The default language for specification in any field is the designer's natural language, such as English, and the initial specifications are generally drawn up on a sketch pad or blackboard. Okay. The initial designs has been or specifications are generally drawn up on sketch pad or blackboards. But natural language specification tend to be lengthy, vague and ambiguous, and therefore often are difficult to prove correct, consistent and complete. Even though initially we are starting with our natural language like English or something, these languages are very lengthy and vague. Some of the information may miss or it may some ambiguous, and therefore often it is difficult to prove correct and consistent and complete. Formal and semi-formal languages have proved their own value in many areas including mathematics, physics, circuit design, music and even teaching. Formal and semi-formal languages have proved their value in many areas including mathematics, physics, circuit design, music and even knitting. So, formal language have specified grammar. In graphical user interface, a grammar might be used to describe sequence of actions, but these grammars tend to be short, making transition diagrams and graphical specifications more appealing. Grammars are useful for specifying textual commands or expressions that a program should understand. What is a grammar? Grammar is meant for specifying textual commands and expressions that a program should understand. In computer programming, Baker's normal form, also called as Baker's normal forms, is often used for describing programming languages. High-level components are used or described by non-terminal and specific strings or terminals. For example, let us see the example of telephone book entry. Telephone book entry, name, telephone number. In that name, what is the last name, what is first name string, last name string, what type of data we have to enter, whether it is string or something. String is nothing but character, how many characters it is, that is the specification. That character consists of what are the words which can consist both capital letters, small letters. Okay, that specification we can give. This is the grammar. Okay, the telephone directory consists of name and telephone number. The name will be specified with the first name and last name. That last name we are going to enter that in the string, and first name and last name we are entering in the form of strings. What is that string? The string consists of some characters. Okay, what are the characters? The characters are nothing but alphabets of both upper class and lower class. Whereas you go for telephone number, the telephone number consists of area code, exchange code and local number. Okay, and what is that area code is 3 digits. Okay, the digit is nothing but the area for any telephone number. That area code consists of 3 digits, and exchange number consists of 3 digits and the local number consists of 4 digits, the total 10 digits. And then what is a digit? Digit is a combination of numbers from 0 to 9. Okay, this is how we are going to specify the things which has to be entered. Okay, this is the example of grammar for entering telephone book entry. Acceptable telephone book entries include the following: Washington, George, just like this is the area code, and then exchange code, and then local number. Okay, this is the example how we have to enter that names and details into the telephone book. And then we are going to menu selection and dialog box trace. The next topic is menu selection and dialog box. The menu selection tree has a simple structure that guides designers and users alike. Okay, the both designers and users has to guide alike. Okay, whatever you are using that menu, whatever the designer is thinking, that same thought should be by the users. Okay, designers are doing something and thinking some else, and users are thinking some else and looking at that they are not understanding. It does not matter. Okay, it doesn't, and it does not work out well. So whatever the designer's view, the structure should guide both the designers and users in the same way, making it an excellent selection style for many applications. Okay, and transition diagram. The menu trees are incomplete because they do not show the entire structure of possible user actions, such as return to the previous menu, jumps to the starting menu, or detours to error handling and help screens. The more general design notation is known as transition diagram, has been used widely. Typically, a transition diagram has a set of nodes that represent system states and a set of links between the nodes that represent possible transitions. Each link is labeled by the user action that selects that link and possible computer responses. If you see here, this is the transition diagram. First start. If error occurs, then you are going for error and it will get solved. And then if you want to quit, you can quit, or if you want to go for help, you can go, or you want to add new things, you can add by, if you see the number 1 arrow, it guides us to add new things. If it is number 2, the line 2, it is going to give reverse. Okay, if you want to change that one, that is give reverse. And third action we are going to perform is read action you can perform. And the fourth action is if you want to do some function, you need some help, then you are going for help. And fifth, you are going to quit. On last one is if error occurs, then you are going to start. Okay, this is how the transition diagram has been drawn. And then state charts. Although transition diagrams are effective for following flow or action or to keep tracking of the current states and current options, they are rapidly become large and confusing. A unified modeling language, an emerging industry standard for visualizing and documenting software systems, also uses state charts for specifying the behavior of general programs. Thus, they should be familiar to software engineers. State charts can also be extended with the data flow and constraint specification, plus embedded screen prints to show the visible states of graphical widgets. If you see the state chart diagram, how the states has been changing from one to another. Okay, the bank transaction, first you have to, that the black dot is nothing but starting state, and then the first state is ID verification. Okay, after ID verification, either you can get the cash, nothing but if you want to withdraw cash, you can withdraw it, or you can deposit your checks. If you want to deposit, you can deposit it, and out of box, if you are able to see, you can take the help for doing these transactions, or you can quit that particular transaction. Okay, so whatever we are doing, we are following some pattern. That pattern is called state chart. Okay, first we are in start state and then verification stage, whether you are a valid user or not. Once it is verified, what are the function you are going to do that? Okay, whether you are going to withdraw the cash or you want to deposit the cash. Those are the two functions we want to do with that particular bank transactions. Okay, this is how we are going to draw the state charts. And summary of specification methods. Given the growing interest in software quality in industry and the rise in UML tools, linking specification, interface building, verification and evaluation may soon be available.